Okay, so the goal for our opener here is to just give you an exposure to what these new formulas are going to be. So you've got sine 50 and cosine 50. I actually, calculated these values first, 0.766, and this one's 0.64278. And so what about this one? 1 minus 2 sine squared 25 is equal to which one? Sine or cosine 50? This is equal to cosine 50. Oh, my pencil's not working. This one's equal to cosine 50 degrees. So you have to be really careful how you enter this into your calculator. So when I did this one, so 1 minus 2, and then I did parentheses, sine 25, and then I squared it. Okay, how about for number 2? Okay, so before we do that, I want you to pay attention here. So this is saying 1 minus 2 sine squared of, say, x is equal to the cosine of 2x. This is a formula that we're going to talk about today. It's a double angle formula for cosine. So this one here, cosine squared 25 minus sine squared 25. What does this equal? Also cosine 50. And so again, you can sort of see where we're going today. Also a double angle formula for cosine. We're going to derive these so you can see where they come from. How about this one, 2 sine 25 cosine 25? This is sine 50. How about this next one, 2 cosine squared 25 minus 1? Cosine 50. And how about this first root one, 1 minus cosine 100 over 2 under the root? Sine 50. And the last one? Cosine 50. Okay, so these are actually not all of the formulas we're going to talk about today. These are some of the formulas that pertain to the double and the half angle formulas. The thing is that if you understand the sum and difference formulas for sine, cosine, and tangent, then you're able to derive all the double, half angles, and the power lowering equations. Okay, so we're going to start by, like I said, deriving all of the formulas. So we're going to start with sine. Okay, so I've got sine 2 alpha. So I can write this as sine alpha plus alpha. And so then I can use my addition formula for sine in order to expand. So this is going to become sine alpha cosine alpha plus cosine alpha sine alpha. And another way to write that would be, yes, 2 sine alpha cosine alpha. So this is your double angle formula for sine. So sine 2 alpha equals 2 sine alpha cosine alpha. We saw that here in question number 3 on the opener. Okay, so cosine 2 alpha, this one has a couple of different versions. So we saw 2 different versions here in number 1 and number 2. So there's actually 3 different versions that you can see. We're going to start deriving it in the same way that we did with the sine. I can write this as cosine alpha plus alpha, and then using my addition formula, cosine alpha plus or minus? Minus sine alpha sine alpha. Well, that turns into cosine squared alpha minus sine squared alpha. This is one of the 3 double angle formulas for cosine. Now the other 2 versions of this come from the Pythagorean identities. So we could substitute cosine squared with 1 minus sine squared. And what does that simplify to be? 1 minus 2 sine squared alpha. So this is another version of the double angle formula for cosine. And just like we did before, substituting Pythagorean identity, we can do the same thing here. We could write 1 minus 2 and substitute sine squared with 1 minus cosine squared. And so this becomes 1 minus 2 plus 2 cosine squared alpha, which turns into 2 cosine squared alpha minus 1. So these are the three versions for cosine of the double angle. And like I said, because these are all coming from the addition and subtraction formulas, so far it's only the addition formula, you can really derive them if you need to. Okay, so then for tangent double angle formula, this again means tangent of alpha plus alpha. And so then if we use our addition formula for tangent, this is going to be tangent alpha plus tangent alpha all over 1 minus tangent alpha times tangent alpha. So in the numerator, we've got 2 tan alpha and 1 minus tan squared alpha. So tan of 2 alpha is here. Questions so far? Okay, so these are called the double angle formulas. What we want to do sometimes, though, is we want to reduce powers. And it's kind of interesting. Some books call the lowering powers formula. Some of them call it the formula for lowering powers, and other books call it the half-angle formulas. Our book refers to them as lowering powers. But in calc next year, you're gonna use these lowering power formulas as half-angles. They're directly related, and I'll show you how they're directly related. Okay, so we're going to derive all three of them, the sine, the cosine, and the tangent. And you can derive them all from the cosine double angles. So we've got the cosine double angle, which is cosine 2 alpha. And remember, there's three versions. One of them involves just sine, 1 minus 2 sine squared alpha. Okay, if you don't believe me, you can just flip over and look at that one again here. Okay, so what this means is that if I have a situation where I've got sine squared and I want to try to lower the powers, bless you, I want to try to lower the powers. Right now it might feel a little bit like, what do you care about lowering powers? Well, when you take derivatives and antiderivatives in calc, you have only certain derivative formulas that apply when you have certain powers. And so you will be wanting to lower powers at a certain point. Okay, so what I want to do is I want to solve for sine squared. So we're just going to subtract. And then we're going to divide all terms by -2. So I get 1 minus cosine 2 alpha over 2 equals sine squared alpha. So I'm going to just reorder this and write sine squared alpha equals 1 minus cosine 2 alpha over 2. This is the formula that our book calls formula for lowering powers. Next year, you'll see it written as the half-angle formula. And the reason why you can see it as a half-angle formula is because you've got this angle, which is alpha, and this angle, which is 2 alpha. And so we've got half of what the angle is for cosine. So we're going to derive the other two equations for lowering powers from the cosine. So we have cosine of 2 alpha. There was another one that involved just cosine. Do you remember what another double angle formula is that just involves cosine? 2 cosine squared alpha. Plus 1 or minus 1? Minus 1. So we go about deriving the lowering powers formula in the same way. We're just going to get the cosine squared thing by itself. So cosine 2 alpha plus 1 equals 2 cosine squared alpha. Divide all terms by 2, and I'm just going to go straight to writing it here. And I'm going to reorder it as 1 plus cosine 2 alpha over 2. Okay, so these are the two. Okay, so the last one is the tangent, and the way to do tangent, you've got tangent squared alpha. This one, you just go straight from using the relationship of sine and cosine for tangent. So tangent squared I could write as sine squared alpha over cosine squared alpha. And then I can just use these two formulas that we derived already for lowering the powers. So sine squared alpha is over here, 1 minus cosine 2 alpha all over 2, and then all over 1 plus cosine 2 alpha all over 2. And so then, since the denominators are matching here, they're going to cancel each other out. We're going to get 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. And here are your three formulas for lowering powers. Like I said, in calc, these are going to be called the half-angle formulas. And there's a little, like, I don't know, silly thing that you can use to remember them. It's kind of silly. But, you know, I don't memorize all of these formulas. Either I derive them or I do remember some, like, little silly thing. This one here, if you remember, psycho is bad, negative. What do you think I'm going to say here? Cocoa is good. It's positive. I did not make this up. You can talk to Miss Pickett. So this is a silly little way that you can remember these formulas for lowering powers. So psycho is bad, negative. Cocoa is good. Cocoa, positive. They're the same formula, just with a little bit of alteration. Okay, so to go from these formulas for lowering powers into the half angles, okay, you really do have a half angle relationship because one angle is half of the other. But your book likes to write it in a specific way so that you have, instead of alpha, you have alpha over 2. So if you have sine squared alpha equal to 1 minus cosine 2 alpha over 2, what we're going to do is we're going to let alpha equal to u over 2 and do a little substitution. Okay, so if I plug in u over 2 for alpha, I'm going to get sine squared u over 2 equals 1 minus cosine 2 times u over 2 all over 2. Okay, I'm showing all of my work here. So this turns into 1 minus cosine u over 2. Now, when I want to get the sine u over 2 by itself, we're going to square root. And when we square root, we do have to consider that there's a plus and a minus. And the sign is going to depend on the quadrant. That u over 2 lives in. Well, that says it up here too. So here's your half angle formula. Okay, it's essentially the same thing as the lowering powers formula. So if we go cosine squared alpha equals 1 plus cosine 2 alpha over 2, cocoa is good. We go through the same process. I'm going to speed this up here. Cosine u over 2 is going to be plus or minus 1 plus cosine u all over 2. Here's your half angle formula for cosine, if you follow the exact same steps here. All right, last one, and then we'll do some examples. So if you take the lowering powers formula for tangent, which is 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. And we do this u substitution as well. Let alpha equal to u over 2. This is going to be tangent squared u over 2, 1 minus cosine u over 1 plus cosine u. And so tangent of u over 2 is plus or minus root 1 minus cosine u over 1 plus cosine u. Here's the half angle formula for tangent. Now this is only one of 3 possible versions for tangent. You've got a root here which has a fraction in it. Some people don't like to have fractions in their roots, and so you could rationalize. So if you rationalize this, and I multiplied by 1 minus cosine u on the top and the bottom, you can derive one of the other ones. So I'm going to multiply by the conjugate as one way to eliminate our root. So if we do that, we end up with 1 minus cosine u quantity squared. And then if I multiply this conjugate together, we end up with 1 minus cosine squared u. And this is still all underneath the root. I know my root is not going all the way around there. Okay, well, so what is 1 minus cosine u quantity squared under a root? 1 minus cosine u. What is 1 minus cosine squared u? Sine squared u. And what's the root of sine squared u? Sine u. So this is another half angle formula for tangent. Now, if you didn't like multiplying by the conjugate here, and you wanted to multiply by 1 plus cosine u, you could multiply by 1 plus cosine u. Let's think about what happens in the top. If I have 1 minus cosine u times 1 plus cosine u, that's going to turn into 1 minus cosine squared u, which is sine squared u, and the square root of sine squared is sine u. And in the bottom, if this was 1 plus cosine u times 1 plus cosine u, it would be 1 plus cosine u quantity squared. Under a root means 1 plus cosine u. So this is a third version of the half angle formula for tangent.